Hi, welcome back. This is part 2 of our lecture video for section 2.7. So we're going to pick up at number 9, working on related rate problems. So number 9 says if a snowball melts so that its surface area decreases at a rate of 0.01 square centimeters per minute, find the rate at which the diameter decreases when the diameter is 8 centimeters. Okay? All right, so they drew the sphere for us, not a whole exciting thing. There's a snowball, it's a sphere, okay? And in this problem, they gave us that the snowball, the surface area is decreasing. Find the rate at which the diameter is decreasing. So the diameter is there, right? The whole distance across. Okay. So what are we given? What rate are we given? We are given that the surface area decreases at a rate of 0.01 square centimeters per minute. So area, and whether it's surface area or regular area, that's still square units. Notice the square. So I'm just going to use A, not SA. I don't want to use two letters for a variable. So let's call it dA dt. And it's decreasing, so the rate is negative. Okay, so you got to pay attention to the signs. All right, what we need, find the rate at which the diameter decreases when the diameter is 8. So we need d dt. D for diameter. Okay. Now, that should be negative as well because it says it's going to decrease, right? And then the specific moment, okay, is when the diameter is 8. So when d equals 8. That is our specific moment. Okay? All right, so what's the formula that we need? Formula is surface area. So this would be one of those three-dimensional shapes. So look at your formula sheet and get your area formula for a sphere. Okay, surface area is 4 pi r squared. Okay, that is the formula for the area. Now, if you just jump right into this and take the derivative, you are going to have a problem because what's the first rule about step 3? You can only have variables that are listed here. So the only variables I can have in this formula is A, area, got it, D, diameter, don't have it. I have the radius. So I cannot continue with this problem the way it is, okay? But there is a nice, simple relationship between the radius and the diameter, right? Isn't the radius half of the diameter, right? Or you can think of it as 2 radiuses equal 1 diameter, however you want to look at that. So I'm going to put a little asterisk here. We can't have r in our equation, right? We can't have it. So we need to write it in terms of d. So the radius is 1/2 of the diameter, right? Always, radius is half of the diameter. Okay, well, so then we can substitute that in there then. Instead of r, we're going to use 1/2 d. So now step 3 becomes 4 pi 1/2 d squared. Don't change anything else. All I did was change the radius to write it as the diameter. That's still a radius, right? 1/2 the diameter is still r. We have a formula that has a and d in it, and that's the two things that I'm allowed to have. Okay, so again, don't take the derivative yet. We're supposed to simplify. Okay, so let's do that. So 4 pi, now be careful. You're going to square 1/2 d. So you got to square 1/2. 1/2 times 1/2 is 1/4. And you're going to square d. Okay? So now when you multiply 4 times 1/4, those are going to cancel out. So you're left with pi d squared. So that's what you're going to take the derivative of. So I'm going to write that again. A equals pi d squared. Okay? So again, much simpler to take the derivative now than to take it here. You never want to take it until you're done simplifying. All right, so now we're at step 4, take the derivative. So dA dt, and remember the derivative of a is 1 dA dt, so I don't need the 1 there. Pi is a constant. Take the derivative of d squared, that is 2d d dt, okay? All right, then let's move on. I'm going to add a little bit because I wrote way too big. All right, so now, what am I looking for? I need d dt. Okay, so this is a little backwards, so be careful. All right, so let's simplify. So we have dA dt equals 2 pi d dt. So I want to divide both sides by 2 pi d. I'm solving for this. So dA dt divided by 2 pi d is going to give me what I need, the rate of the diameter. Okay? Don't forget your specific moment, d is 8, and don't forget we were given dA dt was negative 0.01. Okay, so I'm going to substitute those in. So dA dt is negative 0.01 over 2 pi times our specific moment is when the diameter was 8. All right, now, you need to be very careful with this. When you have your calculator, I always tell you guys to be very careful because especially if you have the older version of the 83, you have to put the denominator or anything in a numerator or denominator. If there's more than one term, you kind of have to put those all in parentheses or do them first, okay? So I'm going to do negative 0.01 over 16 pi. Okay. And I want to show you something. So again, if you have the newer calculators and it gives you the fraction, then you're okay. Okay. But I want you to just look. If I put in negative 0.01 and divide it by 16 pi, okay, in my calculator, I would think that's right. However, what is your calculator doing? My calculator is taking order of operations. So it's doing negative 0.01 and dividing it by 16 first. And then it's going to take that and multiply it by pi. And that's not what this says to do. This says go ahead and do 16 pi first, then divide it into the 0.01. So I want you to look, if I do negative 0.01 divided by, and then I do 16 pi like this. Okay. Notice I got a different answer. And remember, this is scientific notation. I got to move my decimal back 4 places. The second one is the correct answer. Okay. So again, some of you have the newer calculators and you can get it to show you the fraction already. As long as it's a fraction already, you're okay. But if you're doing it manually like this, you have to be really careful. So we're going to move the decimal place 4 places to the left, which means I'm going to have 3 zeros. Okay, so that would be negative 0.0001989. Okay, just writing that down from there. That's what our rate of change is, and this again is centimeters per minute. Okay. All right, so be very careful on that, okay? A lot of mistakes because you guys don't pay attention to how you're putting things in the calculator. So, and even if you put this in WebWorks, you would want to do this, okay? WebWorks is old school, so you would put it in that way, okay? All right. All right, let's look at number 10. At noon, Ship A is 30 miles due west of Ship B. Ship A is sailing west at 25 miles per hour, and Ship B is sailing north at 18 miles per hour. How fast in miles per hour is the distance between the ships changing at 5 p.m.? All right, so let's look at a picture. So here's ship A is west of ship B, and it is 30 miles. So this is 30. Okay, they're 30 miles apart when we start this process at noon. Okay, 12 o'clock noon. This is where the ships are. All right, ship A is sailing west this way. So that means ship A, we'll call this side A over here, will be dA dt. That's a positive rate. It's getting farther away from B. Ship B is sailing north. So B is going this way, again getting farther away. So both of our rates are going to be positive. Okay, so this side will be dA dt, and then the boat, ship B, will be dB dt. All right, what am I asked to find? How fast is the distance between the ships changing at 5 p.m.? All right, well, at 5 p.m., ship B may be up here, and ship A will be over here, so how far apart are they? Okay, so this is back to a Pythagorean theorem problem. I've got three sides of a right triangle, so I'm going to be using the Pythagorean theorem. Our specific moment is to find this distance at 5 p.m., right? So think about that. We started at noon, so 5 p.m. would be 5 hours later. So we're going to have to do some work over here. All right, but let's get our problem started. What are we given? Okay, we are given the rate, two rates. Okay, I see two rates in this problem that I'm giving. Ship A is sailing west at 25 miles an hour. Ship B is sailing north 18 miles per hour. So I'm given two rates. So dA dt is 25. And I'm also given dB dt, which is 18. Okay. What do I need? Find the distance between, find how fast, that's a rate, how fast is the distance between the ships changing. So we're going to call this side C, so we need dC dt. Okay, so this problem, first one ever, has three variables that I'm allowed to use, A, B, C. And notice, none of these are constant. A is moving, so side A is going to change. B is moving, so side B is going to change. And obviously side C will change as well because the ships are getting farther apart at any given moment in time. Okay, so our formula will be the Pythagorean theorem, which is a squared plus b squared equals c squared. And I am allowed to have all three of those because I have all three of these. And none of those are constant. They are continually changing in the problem. Right? So over here is side B, and this is side A over here. So I know I put B here. Remember, B is moving north. So this was just the starting point of B, but he's up here now somewhere, right? Okay. So let's take the derivative then. All this is fine. So we're going to do the derivative of a squared is 2a, and we got to take the derivative of a with respect to time. The derivative of b squared is 2b. Take the derivative of b with respect to time. And the derivative of c squared is 2c. Take the derivative of c with respect to time. Okay? All right, so what are we solving for? We want dc dt. So we're going to just divide this side by 2c, and then we can cancel those 2's, right? So we're going to take 2a dA dt, and you can do that now if you want to. I'm just showing you the steps. And we're going to divide that by 2c. That will give us dC dt. So we can cancel the 2's. You don't have to, but it just makes it easier to compute. So we're going to do A dA dt plus B dB dt over C. Okay. All right, so look at what we need. To figure out dC dt, we need A. Well, we don't have A. We got to find this length over here. we need dA dt, which I have. B, I'm going to have to figure out B. I don't know that length. I have dB dt, and then I also need C. So I got a lot of work to do over here on this specific moment at 5 o'clock. So at 5 p.m. means 5 hours later, right? We started at noon. All right, well, we can do this. So let's start with A. 5 hours, it's moving. What was its rate? It's moving 25 miles per hour. So ship A, I would take 25 times the 5 hours. So every hour we're moving 25 miles per hour. But I also have to add 30 because remember it was already 30 feet away from, or 30 miles away. Okay, so the distance from this point to where A is at 5 p.m. would be this many miles. So that is 155. Okay, so that's this number. All right, now B started here, so all we have to do for B is take its miles per hour, its rate, times 5. So B is now 18 times 5 away from that point, which is 90. Okay, so again, I'm going from this point all the way here. So that's 25 times 5 hours, this distance, plus that 30. That was the 155. B started off here, so he's moving 18 miles and another 18 miles and another 18. So for 5 times, he's 90 miles away now. All right, lastly is C. So now that I have A and B, I have to use the Pythagorean theorem and find C. Okay, so A squared plus B squared equals C squared. So we have 155 squared plus 90 squared equals C squared. We just have to work that out. So again, C is going to equal the square root of 155 squared plus 90 squared, and that will give you 32,125. So we have a lot of work to do with that specific moment, but we needed all that in order to figure out. So now we got to go back. So you see how we it's 2 different parts going on. So the specific moment I always do separately because I never know what exactly I got to do here until I look at my numbers. All right, so now I have A, that was 155. I already had dA dt, which was 25. I'll now have B, which is 90. dB dt was 18. And C is the square root of 32,125. Again, I am not going to round until I'm working in my calculator. Okay, so now I would put the top in, it divided by the square root of 32,125, and I will end up with 30.658 miles per hour. Okay, so that is dC dt, the rate, only at 5 o'clock. So if I did this at 6 o'clock, I would get a different rate. Okay, the farther they're away, obviously, the less distance will be changing, not quite as far. Okay, all right. You guys make sure if you have any questions, jot them down so we can talk about them in class. Okay. All right, we got 2 more problems. This one is an inverted cone. So this is, look at my units, cubic, so I know this is a volume. Again, try not to let the units throw you too much, but this is going to help you. So when I see a cubic unit, I know there's volume involved. When I see square units, I know that's area. And then the regular units, those are just the lengths, right? So that's to help you make sure that you're not putting a whole lot of time thinking about those units, okay? All right, so let's look at this. Water pours into an inverted cone at a rate of 2 cubic meters per minute. So that's the volume, that's dV dt. If the cone has a radius of 2 meters and a height of 4 meters, find the rate at which the water level is rising when the water is 3 meters deep. So this is your specific moment here at 3 meters, okay? and we see the water coming in at that rate. All right, so again, this rate is volume, so I shouldn't have to think about it. So I am given dV dt, okay, volume, 2 cubic meters per minute. So you guys do need to remember that volume is a cubic unit, area are square units, that you should know, okay? All right, what do we need? We want to find the rate at which the water level is rising. So that's a height. So I need dH dt. Okay, that's what they asked me for. All right, well, the volume of a cone on the formula sheet is V equals 1/3 pi r squared h. Okay, that's the volume of a cone. All right, well, I got a problem. Can only have V and H in my formula, and right now I have R. Okay? So, I got to do some work. So again, I'm going to put a little asterisk. Can't have R in the equation. Okay. All right, well, if I can't have R, how do I fix this? So, they gave me a nice little ratio up here at the top. Okay. They said if the cone has a radius of 2 and a height of 4. So I can set up a proportion, the radius to the height. So the radius to the height, the radius is 2 when the height is 4. Okay, so a lot of these problems are going to give you a ratio, and that's how you're going to get rid of that variable that you need. The last one we did with the radius and the diameter, we already knew that ratio. We could figure that out ourselves, but typically they're going to have to give you it because it depends on how big the cone is, right? So that just depends on that. All right, so now I can kind of cross multiply, and remember I want to solve for R. So this would be 4R equals 2H. So R equals 2H over 4. So that means R is H over 2, okay? Why am I doing that? Because I want to change what R is in terms of H, because I'm allowed to use H. H is fine. Okay, so now I know what R is. So now I'm going to rewrite step 3, 1/3 pi, and then instead of R, I'm going to use H over 2 squared H, and don't change anything else. I still got to keep the squared there. I still got to keep that other H there. Now, do not take the derivative yet. I got all my variables ready, but I don't want to take the derivative because I can simplify. This is way too hard to take the derivative of, okay? So let's keep going and let's simplify. So 1/3 pi, if you square H, that's H squared. And if you square 2, that's 4. And then you got H. Keep going, okay? So remember, pi is in the numerator. And you have H squared times another H. That's H cubed. And in the bottom, you have 3 times 4. So this whole thing would be pi over 12 H cubed. That's way easier to take the derivative of. I just got a single variable here. Okay? So remember, 1/3 pi, pi is in the numerator. Right? That's how you write that. All right, so now I'm ready for step 4, which is to take the derivative. So dV dt, derivative of v is 1, and then derivative of v with respect to t. Pi over 12 is a constant, times the derivative of h cubed would be 3h squared dh dt. Okay? All right, so what are we solving for? Okay, we're solving for dh dt, so we got to do some work. Too bad we're not solving for dv dt. All right, so let's simplify a little bit more. So we've got pi over 12 times 3, so that'll be 3 pi over 12, so that's pi over 4 h squared dh dt. And then I'm going to divide everything by that. So this is where you got to be careful again on your calculator. So dV dt divided by pi over 4 h squared. That's going to give you dh dt. Okay? All right. Do I have dv dt? Yes, that was given to me. Okay, and now I need h, that's my specific moment. So specific moment, I didn't write down before, and you don't have to because this one I'm just using it, but our specific moment is when the water is rising, when the water is 3 meters deep. So that would be when h is 3. And luckily on this one, there's no work to be done. You know, the last one we had to find A, B, and C. On this one, that's all we needed. All right, so we know dv dt is 2 and h is 3. So now I can come and find dh dt. So dv dt is 2 pi over 4 times h, which is 3 squared. So again, be very careful with your calculators. Okay, so this is 2 over pi over 4 times 9. So that would be 2 divided by 9 pi over 4, right? So you could do it that way. You could flip it and multiply, which would be 2 times 4 over 9 pi. So in your calculator, you're actually doing 8 over and then 9 pi, better be in parentheses if you need to. Okay, so that should give you 0.283 meters per minute. This is a standard. This was the height, right? The rate of the height, so regular units. So that's what you should get. Now, you know, you could put this in your calculator right here. You don't have to go through the simplifying. I like to simplify just in my head because I can do that better without my calculator. But you could do 2 divided by pi over 4 times 9. Just make sure that goes in parentheses, okay? So you don't have to do those steps, but just again, in my mind, that's what I'm doing. I like to kind of simplify it that way. And also, you know, if you're taking a multiple choice test, that might be the way it's given to you. So you do need to be able to get to this point, but you know, for WebWorks, you can just get the decimal, okay? All right, let's do one more problem. Okay, number 12. All right, so this one says we have, and we'll get a picture for this one. So a boat is pulled into a dock by means of a rope attached to a pulley on the dock. All right, so first off, this boat is coming this way, so the distance is getting closer, so the rate will be negative, right? The rope is attached to the front of the boat, which is 7 feet below the level of the pulley. So that means this dock is 7 feet high. So this is 7, so that's a constant. So we're going to draw kind of a triangle. Let's make a triangle there. All right. So we have 7, which is going to be that height, so that's going to stay. If the rope is pulled through the pulley at a rate of 20 feet per minute, so if the rope is pulled, okay, so what do we want to call that? Again, you want to call it R for the rope? Do you want to call it side C if you're doing A, B, C? It doesn't really matter. I'm just going to use A, B, and C, okay? I'm going to just call it that. So the rope is side C. So that means I am given dc dt. That's the rate would be negative 20 because it's pulling in, okay? So that's what I'm given, dc dt, negative 20 feet per minute. Okay. At what rate will the boat be approaching the dock when 120 feet of rope is out? So the boat is going to be approaching the dock this way. That's dB dt. So we need dB dt. Okay, right? The boat is not going to be out of the water. The boat is going to be moving this way in the water towards the dock, right? All right, and then we have our specific moment. Will be when what? When what's 120 feet? Would it be C or would it be B? C is the rope. So when C is 120, that's going to be our specific moment. All right, so we're going to use Pythagorean theorem. So Pythagorean theorem, though, I can only use C and B. I don't want to do A squared plus B squared equals C squared. I want to use A as 7. That's a constant rate. So I'm going to do 7 squared plus b squared equals c squared. Okay, so now I have the two variables I'm allowed to use. I don't need a because 7's not changing. So now I can find the derivative. So step 4, the derivative of 7 squared is 0. Derivative of b squared is 2b db dt. And the derivative of c squared, 2c dc dt. All right, we're solving for db dt, so I'm just going to divide 2b over here to this side. So db dt equals 2c dc dt over 2b. Again, you can cancel the 2's to make it a little bit easier to work with. So c dc dt divided by b. All right, well, I have c, that's my specific moment. I have dc dt, negative 20, but what I'm missing is b. Well, if I know that c is 120 and I know side A is 7, I can find b also in my specific moment. So we can find b. So we'd have a squared plus b squared equals c squared, right? A is 7, looking for b, c is 120. So they gave me c, and I already knew 7, so I can find b at that moment. So b squared equals 120 squared minus 7 squared. Take the square root of that number, so that's 14,351. And now I can solve my problem. So that's my specific moment stuff. Had to do work on this one. So you can see all of them are a little bit different. All right, so dB dt is side C, which is 120. dC dt was negative 20. That was given to us. And we just found b to be the square root of 14,351. Okay. So put that in your calculator, and again, this rate is going to be negative, and you should end up with negative 20.034, and these were feet per minute. Okay. All right, so again, keep stressing not to round. Don't round, because WebWorks will not like you, and you will get very frustrated. So, you can put that in WebWorks. Just this has to be in brackets or parentheses. Okay, you don't have to do the decimals. I would stay away from the decimals if all possible. Don't do it. WebWorks likes the exact answer, and those are radicals. Okay, or fractions. Don't change to decimals unless you really have to. All right, so that does it for this section. So keep working on WebWorks. Jot down any questions you have, and work hard and let me know if you have any questions, okay?